All right. First of all, I thank Dr. Singer for that presentation, and I am really pleased that he took the time out to come visit us at Texas A&M. And this is a little bit of something I cribbed from his first slide, and he presented you the NIPCC view and put it as a juxtaposition to the IPCC view. I think it's important for you to realize the full context of this. I'm going to give you the IPCC view, but it's not just the IPCC view. It's actually the view of lots of organizations. So, for example, the U.S. National Academy of Sciences, they say basically the same thing. The U.S. CCSP says basically, the Climate Change Science Program says basically the same thing. The U.K. Royal Society, oops, your time is now up, Fred. That's right. The science societies of all of these countries, NASA, NSF, NOAA, AGU, AMS, the Atmospheric Science Department here at Texas A&M, the UT Climate Science System Group, 97% of climate scientists, and of course, most importantly, Al Gore. So I'm going to be representing the points of all of these people. Now, however, I think it's important to recognize that just because the views that Dr. Singer have are really not reflective of the vast, vast, vast majority of scientists, still, science is a free market of ideas. You always have to defend your ideas. And if you can't defend your ideas, then your ideas probably aren't worth very much. So we always have to take these kind of arguments very seriously. And so what I'm going to try to do in this talk is basically not so much I'll give a partial response to those points, but give more generally the arguments for why we think the Earth is warming and why we think humans are to blame. And so we'll begin by talking about the Earth's warming, because in some sense this is the linchpin of Dr. Singer's arguments. His argument is the Earth is not actually warming, and if that's true, then obviously humans aren't causing the warming. I mean, that doesn't take a PhD in logic to understand that. So it's important for us to understand, is the Earth warming? And so we're going to do a little detour before I really get into all the data and talk about looking at about how you measure the data, particularly on short time scales. So this is a data set that Dr. Singer showed. This is year on this axis. This is temperature anomaly, so it's just a departure from the mean. We've subtracted off the mean annual cycle. And this is from the MSU satellite record, so Dr. Singer showed exactly the same thing. And so you can kind of look at this, and the thing you notice is there are lots of these ups and downs that are superimposed on a long-term trend. And so because there are lots of ups and downs, you have a lot of latitude to get any kind of trend you want out of this. So if you want a positive trend, well, you just start here and end there. If you want a negative trend, well, you start here and you end there. If you want a zero trend, you start here and you end here. And the lesson for graduate students is you cannot look at the data and fit the model. Okay, there's a word for that, chi by eye. And I'll paraphrase Numerical Recipes in C. They say people who practice chi by eye get what they deserve. You cannot just look at this. So if you want to know what the trend here is, you have to actually use a more technical, a more quantitative analysis. And so I have a little video to show how we do this. Okay, so before I get there, so how do we do this? So how do you actually see what the underlying trend is? Well, the first thing you got to realize is these bumps and wiggles are not random. We know what causes them. So this is an El Nino, this is El Chichon, another El. El Chichon. This is a big El Nino, Pinatubo, early in the 90s. We have the super El Nino of 98 here. We have a La Nina here. We have another La Nina here. We have an El Nino here. So these bumps and wiggles have known physical causes. And so we can actually subtract them off, and we can see what the underlying trend is. We can see if what Dr. Singer argued, which is that there's actually no warming, no global warming signal here, and there's a flat global warming signal, there's a jump between them. We can see if that actually stands up. So this is a diagram I got off the Skeptical Science website. And so let's start off with, this is the GISS temperature data. And again, you see, so this is a different record. This is the land surface temperature, or not the land surface, this is the surface thermometer record. And you see it has all these ups and downs in it, so it's just like the satellite record in that regard. And so what we're going to do then is we're going to try to identify the sources. So we know, for example, this big dip is due to Mount Pinatubo. So that's one reason. And then we're going to look at the El Niños. And so, for example, this is a big El Niño. So here's the El Niño index. And then they're going to do, and then the last thing is we also suspect there's a big long-term trend here in global warming. What we want to do is we want to separate those out and subtract off the El Niño and the volcano signal and see what's left over. And we can see then if this actually changes shape, if we actually see a flattening of this right here or not. And so the first thing we have to do is let's subtract off the volcanic signals. You'll see this Pinatubo signal disappears when we subtract off. They're doing just a straightforward multiple linear regression. So now we're going to subtract off the ENSO. And voila, what we have left is essentially the human component of the warming after we've taken out the bumps and the wiggles. And what you see is there's no change in slope. This is there's a warming pre-1997 and there's a warming post-1997, and they're exactly the same. Now, obviously, this isn't perfect. It's not a completely linear system. You can still see some residuals in there. But nonetheless, you don't see at all when you actually fit to a realistic model what Dr. Singer was saying. You don't see a flattening. You don't see this jump. You see constant warming, which is exactly what we think we see in all of the data sets. And so, in fact, we can take this method and we can apply this to all the data. And this is what we get. And this comes up from Foster and Rahmstorf, ERL 2011. So GISS, NCDC, and CREW are 3 surface temperature data sets. RSS and UAH are 2 satellite data sets. And when you subtract off the bumps and the wiggles, they all show this constant, very consistent warming. So what we see is that the data do show warming. The surface data do show warming when you look at it appropriately. All right, now, but the important thing is to look at all the data. This is key because if you look at the data individually and you don't see the multiplicity of the data, then you underestimate the power of what we have. So what I showed you a second ago was the surface and the satellite data. And that's this right here, so that's right there. And those both show warming, clearly. There's no question about it. It shows warming, very consistent. Also, we know that ice on the planet is disappearing. Ice melts reliably at 32 degrees, and so it is disappearing. We see ocean heat content is going up, and we see sea level is going up. And the important thing about this is that these data sets are independent. So the satellite data and the surface thermometer records, there's no reason to think there's any common errors in them. So if one of them's wrong, there's no reason to think the other one's going to be wrong the same way. And in addition, there's 4 different groups that analyze a surface thermometer record. There's 2 different groups that analyze a satellite record. There's several groups that do heat content. There's several groups that do sea level. There's multiple layers upon multiple layers of verification here. And so what you end up with is you end up with this consilience, this idea that all the data fit together. It fits together perfectly. So for example, if you're warming the planet and you're melting ice, where's the water going to go? Grounded ice. The water's going to go into the ocean. So you expect sea level to go up. If you're heating the ocean, that causes water to expand. You expect sea level to go up. And sure enough, sea level's going up. In addition, sea ice. Most of the sea ice we lose is in the Arctic. Well, that's completely consistent with the temperatures. Most of the warming is in the Arctic. The Antarctic is not warming as much. The data fit together. And the sum of the data is far more powerful than any individual data set. You can sit here and you can say, well, there could be a problem in this data set. And that's true, there could be. And there could be a problem in this data set. That's absolutely right, there could be. And there could be a problem in this data set, and this data set, and this data set. And that's right, but could they all be wrong? All be wrong in the same direction, in the same amount? It's essentially impossible to believe. And that's why the IPCC calls this unequivocal, essentially beyond doubt. The warming of the climate system is essentially beyond doubt. All right, so I stole this slide from Dr. Singer. So I think I've addressed this question here about no warming trend since 2002. I think he's not looking at the data correctly. I have to admit I didn't quite understand his Antarctic argument, so I'll have to defer that. Now, the hot spot is very interesting, and I think he's been working on this for so long, he doesn't realize that all of you guys aren't experts in this. It happens to me all the time. I'll be talking about water vapor feedback, and I realize not everybody has read everything on it. So let me just explain what he's talking about here. And basically, we know the atmosphere maintains a moist adiabat, in the tropics. So if the surface warms, you expect the upper atmosphere to warm by maybe a factor of 2 more than that. And so we see a warming of the surface, and we actually do see warming in the upper troposphere, but not as much. Well, I guess it depends on what data set you're looking at exactly. And so there's this disagreement between the two data sets and between our idea that it should be tied together by a moist adiabat. Now, there are 3 things that could be going on here. The surface data could be wrong, the upper air data could be wrong, or the theory tying these 2 temperature levels together could be wrong. And so the National Academy of Science actually looked into this. So this is a report that came out, and I guess about 10 years ago, or maybe maybe even more than that now. And so paragraph 1, page 1 of the report, so this is the second sentence of the report, they looked into all of these things. They say the disparity between the surface and upper air temperature trends in no way invalidates the conclusion the surface temperatures have been rising. So in other words, they looked at all the possible explanations. Could it be the upper air data? Could it be the surface data? Could it be theory? And it's quite clear that the least likely explanation is the surface data are wrong. Could it be? Sure. It could be the surface data are wrong, but it's far more likely the upper air data are wrong. It's a very hard measurement to make. You have to adjust radiosondes. You have to adjust satellites. The radiosondes and satellites, I should say, are not completely independent. The satellites are tied to the radiosondes at maybe not directly over tropics, but at subtropical and mid-latitude. So they're not a gold standard intercomparison. So I think the hotspot doesn't dispute warming. Okay. All right. So I'm just going to finish up now. I'll spend 5 minutes, and I think that'll be my time, on what is the evidence in favor of human causing the warming. So I think I've established, up to everyone to make their own decision, that the Earth is indeed warming. So why do we think it's humans? And so the way I like to think about it is, imagine you're a detective. All right, you come across a house. The house has been burglarized. So the first thing you know is the house did not burglarize itself. There's some cause. Similarly, the temperature's warming. There has to be a cause. It cannot. You'll often hear people say it's a recovery from the Little Ice Age. That is not a cause. That is not a physical cause. Climate change does not. The globe does not warm just because it used to be cold. It doesn't work that way. There has to be a cause. And so we know from a lot of research, oh, this one's gone. Oh, there it is. We know from a lot of research what the various processes, what the suspects in the crime could be. All right, so we know from historical record that orbital variations can affect the climate. But we also know orbital variations are too slow. That's a 10,000-year, 40,000-year, 100,000-year process. We know that the movement of the continents can affect the climate. Again, tectonic processes are too slow. That's a million-year process. We know the sun can change, and that actually is a legitimate possibility. So we cannot immediately eliminate that based on time scale, but we have measurements. We've been measuring the output of the sun for 30 or 40 years, and for the last half century, we can eliminate the sun as a possibility. Volcanoes, I'm not even going to talk about that. It's not volcanoes. Internal variability. This is actually the hardest one to eliminate. I think this is like the suspect who claims he was home playing his Xbox, but no one saw him. But there's no evidence that he has no alibi. But on the other hand, there's no evidence to implicate him. So you're probably not going to convict him. If there's no evidence that says that person did, even though you doesn't have an alibi, you're not going to put him on trial. Internal variability we cannot eliminate, but there's no theory of internal variability. There's no evidence. Nobody can make a positive argument that explains the warming based on internal variability. So, I'll eliminate that, but there's always a question mark by internal variability. And so finally we get to greenhouse gases. Now, greenhouse gases are like the suspect that dropped his wallet at the scene. There's a big handprint on the wall. He was bragging about it to his friends. When they arrested him, he had the stolen stuff in his trunk. Now there may not be a smoking gun, but there's so much evidence you would have no trouble putting this guy away. And so let's talk about what that evidence is. All right, so first off, carbon dioxide is going up. All right, I'm reasonably certain Dr. Singer would agree that carbon dioxide in the atmosphere is going up. Secondly, we've known for 100 years, if you talk to Arrhenius in 1896, he would say, yeah, if you jack up CO2 in the atmosphere, you're going to warm the planet. There's strong theoretical reasons to think that we should be seeing warming. In addition, and this is actually very important, successful predictions. The gold standard of science is making a prediction. If you can make a prediction of something that's going to occur, that is a gold star. You will be famous. And in the 70s, 100 years ago, Arrhenius was making predictions. And in the 70s, Wally Broker said, I predict that in the next few decades, we're going to see several tenths of a degree warming in a paper in Science. And that was when he coined the term global warming. And so that's an incredibly successful prediction. And that's the kind of thing that gives you high confidence. Now, I hope Dr. Singer doesn't mind if I tweak him a little bit here. So I have a book from him. Or actually, I think he gave it to my father. My father gave it to me. Unstoppable Global Warming. And the first... Every 1,500 years. So the first sentence is, the Earth is warming, and it's unstoppable. And then, if you listen to his talk today, whoops. Oh, shoot. The warming has stopped. So anyway, that's an example of perhaps an unsuccessful prediction. But more seriously, I do not think climate skeptics have ever made a significant prediction that's turned out to be correct. And if you ask them, well, what's the temperature going to do in the future? They can't give you an answer. They'll say, well, this is what I think it's going to do. Well, show me something. Show me analysis, back it up. And I'm sure Dr. Singer will correct me if I'm wrong, but there's been no successful prediction, whereas the mainstream climate science theory has made many predictions. Warming in the Arctic will exceed warming in the Antarctic. That was made in the 70s. Cooling in the stratosphere, warming in the troposphere. Lots of predictions have been made that have borne out this theory. In addition, if you look at the paleo data, if you look at the last 100 million years, carbon dioxide explains not every single gyration, but for example, the ice ages. You cannot explain the ice ages without having carbon dioxide have a big impact on climate. Talk to Jerry North. He spent 10 years with his energy balance models trying to simulate ice ages, and then they suddenly discovered that carbon dioxide was a lot lower during the ice age, and all of a sudden, voila, he could get an ice age. You can't get an ice age with modern day levels of carbon dioxide. We have Venus. That's another example that greenhouse gases heat the planet. And finally, as I said before, no alternative. There's no alternate theory that can explain the warming in the last few decades. And then climate models. Dr. Singer in his presentation, I think this was really an incorrect statement. He said this was the only evidence we had. It was the fact that the climate models can only explain the warming when you put carbon dioxide. That's not the only evidence. That's the cherry on the cake, or a cherry on the, what do you put cherries on? So it's an incredibly long and rich calculation. And okay, here's the same thing he showed. I don't go over that. And so again, you have this consilience. No one of these pieces of data would convince you. But put together, you would have no trouble putting this guy away if you were on a jury. It's not beyond a shadow of a doubt. In fact, the IPCC, as Dr. Singer said, calls this very likely, which is 90 to 95% certainty. I think in the next one it will be extremely likely. But nonetheless, it's not, again, when you're on a jury, to convict someone does not require absolute certainty. It requires beyond a reasonable doubt. And beyond a reasonable doubt, the data clearly indicate carbon dioxide is guilty. All right, so let me just conclude this. I think the evidence is very clear that the Earth is presently warming. Arguments to the contrary have never appeared in the peer-reviewed literature, and I would go so far as to say what Dr. Singer argued is unpublishable. I mean, if you sent that to a journal, it would be folded, spindled, mutilated, and sent back to you. I mean, along with a note saying never submit to this journal again. You could. This is in a seminar you can get arguments out that you can't get out in a journal, because in a journal article, you can actually look up the references. You can look up, there was a lot of his time series ended in 2000, for example. They didn't go through 2012, and things like, and so I would challenge him, if he really thinks this is right, to get this into a peer-reviewed publication. If he thinks the Earth's not warming, I will believe it when I see it in GRL or JGR. And finally, humans, I think is a very strong case that humans are very likely to blame for most of the recent warming. And I'll summarize there. Thanks.
I hope you can all hear me. Thank you for this nice introduction. And thanks also to Professor Dessler for inviting me here and giving me 30 minutes. which means I will finish at 4:35. Just want to document that. I've spoken to some of you before by telephone. You may remember that, about a year ago. To those who haven't heard me, you're looking at a real live skeptic, climate skeptic. You may now have seen one before. You may never see one again here at Texas A&M. I don't know. Anyway, some of you refer to me as a denier. There are a few who call me a criminal. That's rather sad, but I will try to show you evidence based on data. I'm very data-oriented, and the information I will show you is not generated by me, but is generated in reports by the NOAA, by IPCC, and by other reputable bodies, and based on various kinds of observations. First, I need to explain what NIPCC is. We are a relatively new organization, about 5 years old. It stands for Non-Governmental International Panel on Climate Change, as opposed to Intergovernmental Panel on Climate Change. In other words, we're not supported by any government or anyone else for that matter. Mostly all volunteers, but trained atmospheric scientists, about 30 of us. And we've now published several reports, some of which have just been translated by the Chinese Academy of Sciences into Chinese. I've written a preface stating that I can't read Chinese, and therefore I'm not responsible for what's in the book, because I don't know what's in it. I can't read it. Anyway, I just want to show you that at least in China, we're considered to be very respectable. And other places too. Now, we will publish our final report later this year to coincide with the publication of the 5th assessment report of the IPCC. I will quickly take you through this. We were founded 10 years ago. We've been actively operating for about 5 years. We have all of our reports are available on the internet for free. You don't have to pay for it. Just type niPCCreport.org. I don't know about the Chinese reports. Maybe they're available too, but I can't vouch for it. The IPCC is okay as far as it goes. I'm what's called an expert reviewer of IPCC reports, and I take my responsibilities fairly seriously. It's not a very distinguished position to hold because one can volunteer for it and one gets approved. And I've now gone through these reports, and the most recent one, where I've reviewed the second draft just last November, I find that IPCC tends to ignore certain sets of data. For example, they ignore 3 major disparities. I will point to them quickly. One is that there was no warming trend since at least 2002. Some say there's been no warming trend for the last 15 years. I'm more conservative. I will vouch for the fact that there's been no real trend, a discernible trend at least, in the last 10 years, while atmospheric CO2 has been increasing rapidly. And that needs to be explained, of course. They don't explain it. I will also show very quickly that the Antarctic agrees with modeled warming, but the polar regions are very peculiar. They don't agree with the models at all. So maybe the models are not designed to discuss what's going on in the polar regions. The third item, which I will touch on, is the so-called hotspot. If you look at the second IPCC report, they use that as a fingerprint to argue for anthropogenic global warming, AGW. You'll hear me talk about AGW frequently. It means anthropogenic global warming caused by human-released greenhouse gases. We, of course, agree that CO2 is increasing in the atmosphere as a result of human activities, and we also agree that CO2 is a greenhouse gas. So there should be a warming effect from the increased CO2. We don't detect an appreciable effect in the actual data, but of course it's shown in the models. So the models predict a hot spot in the tropical atmosphere, up to twice that of the surface, but the satellites and radiosondes don't show it. Very peculiar. And the IPCC has used this as an argument bearing on AGW. In fact, in the second report, they try to show that this hotspot does exist in the observations. I think they fiddled the observations, and I will try to show you that a later U.S. government report and also our own work doesn't show the hotspot. We have used that as an argument against anthropogenic global warming, but I think that's wrong. It doesn't really say much about about the source of global warming one way or the other. It is really an indication, as we've discovered, of the fact that in the tropics you have a lapse rate which is dictated by moist adiabatic effects. Water vapor plays an important role, and that's what causes the amplification. Now, with this brief introduction, let me turn to some of the data. The first, here I want to show the satellite data of the last, since 79, so almost 30 years, more than 30 years now, and you see in the satellite data, in blue, oops, here we go. Yeah, I have it here. Just a matter of finding it. Okay. Yeah, here it is. Essentially no trend. This is identical with figure 2.3 in Professor Dessler's book, published last year. So we agree on the satellite data. You'll see also the 1-year spike caused by Super El Nino. Ignore that for a moment because it doesn't have any bearing on anthropogenic global warming. You see here a step increase between 2001 and 2002. Very strange, we don't know what's causing that. Some change in the regime of the Earth's atmosphere. And then again, no change, zero trend in the last 10 years to 2012. In the meantime, carbon dioxide, shown here in green, has been rising steadily, but it doesn't seem to have much effect on the satellite data, on the atmospheric temperatures. On the Antarctic and Arctic, we're still trying to figure out the situation. We've discovered peculiar things taking place. Some change in the regime at around 1994-95. It changes distinctly from cooling to warming in the case of the Antarctic. In the case of the Arctic, there's also a change, and it has seasonal effects. We've tried to figure out, and I won't go into any details here, how the Antarctic ozone hole might affect temperatures in the Antarctic. And I'm trying to pursue this, and hopefully we will come up with some kind of a publication that could explain it. In any case, the IPCC ignores this issue. Next, I'd like to show the hotspot controversy, which dates back to the second IPCC report, where they argued, there's a paper, a chapter on attribution in that report. They argue there that the modeled and observed trends in the atmosphere agree. In 2000, several years later, the National Academy of Sciences set up a panel to try to reconcile surface and atmospheric trends, and they decided they couldn't reconcile them. They gave up. In 2004 and 2007, Douglas and Christie and I published papers showing that there is disagreement between the modeled and observed trends in the atmosphere. And in 2006, Santa, as lead author of a report of the U.S. government called the CCSP report, showed that the hotspot is not seen in the data. But then he changed his mind, and then in 2008, he published a paper in the International Journal of Climatology claiming that the hotspot is consistent with observation. Modeled and observation are consistent. In 2011, I tried to show that there's no consistency. So we have a standoff right now because we haven't gotten his latest comments on our paper. I may have a chance to say something about this in discussion. It turns out that it doesn't have the sort of relevance to AGW that we thought it did. We were misled by the original IPCC report. I think it is more relevant to the question of the moist adiabatic lapse rate that exists in the tropical zone. This shows the hotspot as modeled. And there's nothing wrong with the models here, by the way. They do show the expected increase in trend from the surface to about 10 kilometers. This is the equator here. This is the North Pole, the South Pole, just to orient you. And you see the hot spot. This is not temperature, but temperature trend. That is degrees per decade. These are the observations. You don't see the hot spot, do you? This comes from the government report called CCSP 1.1 of 2006. Ben Santer was the lead author in this, and it contradicts his conclusion in the IPCC because he was lead author of that chapter also. So he's changed his mind several times. Maybe we'll finally pin him down. This is a graph published by Douglas et al. It shows that the models show an increasing trend with altitude, and the observations show a decreasing trend with altitude. You see here altitude in pressure, altitude in kilometers, and this is trend values over here in degrees per decade. By the way, just to show you, the satellite data, as far as we can tell, agree with these balloon observations by radio sondes. Although these are very tricky things, radio sondes corrections need to be applied, but satellite correction needs to be also applied. So some people might argue that this agreement is a coincidence. I like to think that it's real. In any case, you see here the strong disagreement between models and observations, and there's still a lively debate on this issue. This is the latest from Ben Santer, taken from his paper in the International Journal of Climatology. I need to orient you on this. It's an important graph. Here's trend, zero trend, negative trends, positive trends, and here's altitude. And you see 1, 2, 3, 4, 5, 6, 7 sets of trend values which are supposed to be observed. How can this be? You can't have 7 different trend values. You can only have one. The real atmosphere only has one set of trend values. And in fact, it is these two here which agree very closely, one by NOAA and the other by the Hadley Center in England. And you see that they strongly disagree with the modeled trends, which are shown by this heavy black line, and the uncertainty is shown by the gray area. Now, these additional ones shown in this graph here, several of these do overlap with the models. But I think I will argue, and I have argued, and I've published on this, that these trends, these so-called observed trends, don't really exist. They're published, but that doesn't mean that they're real. They're published, but they're not real. Santer claims that they all agree, all 7 all these 7 trend values with altitude agree with satellites. That's shown here. What does that prove? It proves that he's used the wrong discriminant. Because if you can't discriminate between this trend and this trend, you see this a negative trend here and a large positive trend here. If you can't discriminate between them, it means your discriminant is no good. Well, more recently, we've shown that if you use the right discriminant, you can judge which of these trends agree with satellites, and the only ones are these 2 here. The other 5 do not agree with the satellites. And this has been independently confirmed by investigator Jiang Fu at the University of Washington, who has used a similar approach that we have, but not exactly the same, to confirm what we have found. So we're fairly sure about that. IPCC, we're now going on to the 5th assessment report. Well, actually, this is from the 4th. The 4th assessment report says the same thing as the 5th assessment report. The 4th assessment report says in the summary, it's the summary for policymakers on page 10, it says that most of the observed increase in global average temperature since the mid-20th century is very likely due to observed anthropogenic increase in greenhouse gas concentrations. Very likely in IPCC language means more than 90%, between 90 and 99%. The current report, the number 5 report, which will be published in September, says exactly the same thing, except now they're 95% sure. I suppose the next report will be 99% sure. I'm not so sure at all about their conclusion. So where do we go to find the evidence to back up this statement? It's on page 684. So after you read page 10, you have to go through many, many chapters till you get to chapter 9, figure 9.5, and then you find on page 684 a graph that shows a gap between the recent temperatures, unforced models, and therefore they argue it requires a greenhouse forcing. That's their proof or their evidence for greenhouse forcing. This one graph. I'll show it to you. Here it is. This is the graph 9.5, and here you see the reported, I won't say the observed temperature values, the reported values from global surface temperatures, and the blue are the modeled from models that do not have greenhouse forcing. And you see this gap here? They argue that this gap is evidence for greenhouse forcing, because if you add the greenhouse forcing in the right way, then you can agree with these temperatures. I will now give you my argument in very brief form. Look at the observed temperature increase. You see a rise in temperature here between 1910 and 1940. Can you see it? Oh. Yeah. It kind of disappears. Do you have a better one? The backup. Thank you. Oh, this one is good, yeah. Between 1910 and 1940, you see this rise here? That's real. There's a real temperature increase between 1910 and 1940. Anyone here remember this? No? Too bad. I don't either. I was too young then. I remember this decrease because there was great concern about global cooling in the 70s. Any of you remember that? There might be some in the audience that remember this. A great concern. Time magazine and Newsweek carried stories about the coming ice age, front page stories, and they were pleased to the government to do something about the coming ice age. Well, the ice age never came, because suddenly the thermometers at weather stations reported this increase. I will maintain that this increase is spurious. It is, at least it's problematic. It may not really exist. And the way in which I will try to show this is to look at other data sets. And you will see that none of the other data sets show this increase. I look at 5 other data sets that are available in the literature, reputable data sets, and they don't show this increase. So maybe this increase doesn't really exist. And if there's no increase in temperature here, then there's no gap. And if there's no gap, there's no evidence supporting AGW. That's my story, in short. All right. Quickly now, I have a few more minutes. There are many missing forcings in the so-called forcing shown here. Oops. And here a listing of missing forcings. Mainly solar variability, cyclical atmospheric ocean oscillations, and many others, including realistic aerosol effects. This is from the 5th assessment report, and you see the same thing here. Here they show the observed, or reported rather, surface temperature, global surface temperature. This is the unforced model. You see the gap here? And the question is this gap real? And this depends entirely on this temperature curve being real. So that's essentially my story. Our story. I've now listed these things for your pleasure. You see here the difference between the 1940s and 1990s. The global surface temperatures reported by the IPCC show a difference of about 0.5 degrees. The U.S., on the other hand, as published by GISS, that's Glotta Center in New York, Jim Hansen, they show no difference, 0. The oceans show no difference. The satellites between 79 and 97 show no difference. The proxies show no difference. So you see, every other data set is essentially showing no difference between the 1940s and 1990s, except there's one data set used by the IPCC, which is the global surface temperatures reported by weather stations. So you begin to wonder whether that is real. This is a good example of the situation. This is published by BEST, Berkeley Earth Surface Temperature. It shows the warming between 1910 and 1940, the real warming, the cooling, and then they show this warming here, which I say may not be real, but it's shown by NASA, NOAA, Hadley Center, and Berkeley. It's no wonder they all agree. They all use the same weather stations. So they all use the same raw data, but they handle them in slightly different ways. Okay, this is the U.S. temperature. You may not have seen this. U.S. temperature doesn't show this major warming. It shows the 1940s warmer than the 1990s. That's now been verified in a number of ways. So there's little question about this. The only argument that people make is, well, the U.S. is only 1.5% of the Earth's surface. Still, Western Europe shows the same thing. Russia and China do not. Why are these differences? Why do they exist? We'd like to find out. We don't know the answer yet, but we will find out. This shows the atmospheric data. You've already seen them, both for global and tropical. It shows no warming during this crucial period. 5 minutes, thank you. It shows this jump, and again, no warming after 2002. sea surface temperatures are very hard to interpret, mainly because there's so many different ways of measuring them. The blue is buckets, the green is inlet temperatures, the red is buoys. So you see, over the last 100 years, the methods of measuring have varied, and they measure different levels of the sea surface. The buoys obviously float at the surface. The inlet temperatures are where the ship's engines are, down maybe 10 meters. And they give conflicting results, as shown below. But anyway, the people who work on this are very clever, and they finally figured out a way of doing this. Here you see the NMAT, the nighttime marine air temperatures measured at the decks of ships with real thermometers. And you see the 1940s, again, about as warm as the 1990s. Well, these are measurements over the sea surface of air temperature. This is sea surface temperature of the water, just published in GRL last year. And you see the 1940s, again, about as warm as the 1990s. So every data set I've looked at, including proxies, show essentially no warming between 1940 and 1990s. The proxies, I'll give you another example here, show the warming between 1910 and 1940, maximum 1940, and then nothing. Another one, this is from England, from the Climate Research Unit at East Anglia University. You see the warming up to 1940, the cooling, and then nothing. They don't show the warming. This is Esper, published in Nature last year. Look at this insert here. It shows the warming up to 1940, cooling, and maybe a slight recovery, but not the major increase shown by surface thermometers at weather stations. More proxy data, all showing the same result, no warming in the last decades of the 20th century. Conclusion? I conclude that the IPCC's claim for AGW is based on flimsy evidence and mainly based on global land surface temperatures. We find no independent evidence for these temperature data in ocean, atmosphere, or proxies. In other words, no gap between the unforced models and the surface temperatures. And we conclude the current warming is mostly natural, that the human contribution must be there, but it's minor, it is not significant. Thank you.
You want to come up?
Turn on the lights. Right. Okay, so we have I have 7 minutes on my phone. Please, I'm going to open the floor to questions for both Dr. Singer and Dr. Dessler. Dr. Singer, can you go through?
Come on, somebody's got to have a question.
Can I ask the first question?
Sure, please.
I have two questions. Of Andy, my friend. What caused the warming of 1910 to 1940?
Okay, so if you read the IPCC, that's officially unattributable because it could be humans, it could be the sun. We just don't have data on that. You need solar forcing data to be able to separate those out, and so we don't know. And that's one of the reasons why the IPCC only talks about the last few decades.
Okay. And my other question is, what is your opinion about the hotspot observations? Do you think the tropical atmosphere has a temperature trend or not?
Okay, so maybe I should turn the microphone off. This way, I'm not convinced by the Santer arguments that they've resolved the discrepancy. But like the NRC report, my money is on the upper air measurements. I think that you look at the UAH and the RSS stuff, it's just not convincing that they've gotten their trends right. And the radiosonde data, just to give you, I think I have some extra slide on that. Maybe I don't. All right, well. No, all right, I don't have a slide. But the radiosonde data has all sorts of problems in it also. So my bet is it's the upper air data. That will eventually turn out to be the culprit. But I agree with you that there's an issue there.
Okay.
I'm not convinced that they've solved that.
I have a third question. May I ask? Do you believe in the existence of a specific decadal oscillation? Do you think it is real?
Yeah. Okay. So if you ask the question, so let me rephrase it a little bit. So if you ask the question, why was the short answer is yes. And if you ask the question, why was there not much warming from 1940 to 1970? I think there's emerging evidence. The argument has always been it's aerosols. And I think there's emerging evidence that it's actually some sort of long-term variability in the ocean. There's a nice paper by Mike Wallace in PNAS, Tim Del Sol. And so I think that's an active investigation. But let me make a point here about sort of impossible expectations. There can be, you can not understand everything and still be very confident that the warming in the last few decades is due to carbon dioxide. You can't set up a situation where if I find anything wrong with your model, if I find any weakness in your argument, that means you understand nothing. That's you're setting essentially impossible expectations for science. And I think that if you talk to people at meetings about the hotspot or about the PDO or anything, you get a range of, it's an active scientific argument. There's a range of opinions, but nobody would say that shakes their confidence in this fundamental idea that carbon dioxide is now the dominant controlling influence of the climate.
I'll save my other question for later.
Dessler commented that your results are unpublishable. Did you ever try to get some published?
I'll repeat it. Good.
Did you ever try to?
Is that to me?
It?
Yeah.
Yeah. Did you ever try?
I couldn't hear the question.
I'll repeat it. So Rennie's asking if you have previously tried to publish any of this, no warming. If you've tried to publish this.
That's fairly new. I'm about to write this up, and hopefully we'll get it published. I've only in the last year put together all of these data sets that I showed, and therefore it is reasonably new. And my interpretation of the hotspot is also new. That is only in the last few months. So I'm giving you results that have not yet been tested, as it were, in the hot fire of
crucible of science.
Yes. The crucible of science.
Sarah has a follow-up.
Okay, so this is for either or both of you.
What's the question?
I'll repeat it.
So when there is mainstream science, do you think the peer review process still works? Is it fair?
All right, so the question is, do you think the peer review process is fair?
The peer review process is about the best we have currently available. I don't think it is really either fair or certainly not perfect. A lot of stuff gets published that frankly is junk.
I agree with that. But I would also argue that people bend over backwards to be fair to the climate skeptics when they submit. Lindzen stuff, Spencer stuff. I mean, that stuff gets published.
That's arguable.
Well, but I mean, your stuff gets published. You showed a whole list of papers that have gotten published. So you can't say people don't.
Read the ClimateGate emails, and you'll see the efforts that people went to of alarmists to stop us from publishing, to organize referee reports that would turn down papers saying this paper should never be published because it'll hurt our cause.
But it didn't. But your stuff still got published. I mean, you showed a whole list of papers that are getting published. So this and Lindzen and Spencer, they get their stuff published. And so I mean, I think that the community bends over backwards to make sure that we don't squelch a legitimate dissent. Now, some papers that get just like the junk. The pro-global warming junk that gets published, there's anti-global warming junk, and that stuff rightfully gets kicked to the curb. And so I think the peer review system, it's no less fair than it is for anyone else. I mean, we've all had papers that we think are good get rejected. I mean, that happens to everybody, and I've seen terrible papers get published. So, it's as Fred says, or I guess paraphrasing Churchill or someone, democracy is the worst system, but for all the others, peer review is the worst system except for any others. So,
yeah, I agree with that.
Yeah. I'll repeat it. All right, so the question is, a lot of your graphs stopped in 2000, the NMAT and GIS US record. So why did you stop those plots? Because I know the NMAT goes on, I know the GIS record goes on. Why did you truncate at 2000?
I try to quote published papers. In many cases, they stop in 2000. And also, the IPCC stops in 2000. They refer only to the last decades of the 20th century. I interpret this to mean from about 1970 to 2000. I don't have any ulterior motive on this, but I'll be happy to always look at all the data. Incidentally, while I'm at this, let me say that I try not to appeal to authority. I'm impressed by the fact that so many academies of sciences have endorsed this. I can assure you they have no idea what they were endorsing. I noticed Albania was absent. I looked for it. Albania is a very important country. Zimbabwe was present. Yes, Zimbabwe, it goes from A to Z. And I'm really impressed with all of the listing of the academies. But the Chinese Academy of Sciences has now published our work and at least translated it and published it. That doesn't mean they necessarily endorse it, but it does imply some kind of endorsement, and I'm very pleased about that.
All right, so it's 5. So people need to go. I mean, maybe Professor Singer and I can stay for 5 more minutes. People need to go at 5. We know there are people who have child care issues, so just sort of discreetly head to the. But if there are other burning questions, is there a question up there? Or, yeah.
My question is regarding, a lot of the warmest years, not only in U.S. history but world history, according to many sources, not just a single source, have said that several of the warmest years on record within the last 15 years, including the United States, have the warmest year on record last year. Do you think they're just getting their data from the wrong source? And if so, what source do you think everybody's getting their data wrong, and why is it wrong here?
All right, so the question is, can you explain why, the last, 10 of the last 12 years were the hottest years on record. Last year was the hottest year in the U.S.
Sure, I can explain that.
Yeah, can you explain that?
Yeah. That is a very important confusion, which I would like to clear up now. There's a difference between the level and trend. Level of temperature is measured in degrees Kelvin. Trend is measured in Kelvin per decade. Now, there has been warming in the 20th century. We know that. The warming between 1910 and 1940 is real. And therefore, any temperature after 1940 must be greater than temperatures before 1910. And that is also the reason why glaciers are melting. It's warmer now than it was 100 years ago. And ice has a long memory. It doesn't melt immediately. You put ice in your highball glass, it doesn't disappear. It takes some time for the ice to melt. And glaciers are not good indicators of global warming. They only tell you that it has warmed in the past.
Yeah, but just to interrupt, but to bring back to this point, these arguments that like last year was the warmest, it's not coming from glaciers. It's coming from these surface and ocean measurements.
Certainly, the 21st century has been warmer than it was 100 years ago.
Was it warmer than it was 20 years ago?
20?
Yeah. I mean, if this is the warmest year, it's got to be warmer now than it was in the 90s and the 80s.
No,
and
no,
70s.
we're talking about the 21st century.
Yeah, that's right.
The whole since, say, 2002.
Right.
Yes, I think it is warmer. because of this jump or discontinuity that I see, at least in the data, between 2001 and 2002. That's been a distinct warming.
Okay.
I don't know what it's due to, but it's not due to carbon dioxide.
What is it due to?
So he asked, yeah, do you have a theory for what it is due to?
It may be, no, I don't have any, I don't try to theorize too much about things I don't understand. I prefer to think that the atmosphere is a very mysterious object that shows unexplained changes, oscillations on various time scales. The most important ones are the North Atlantic oscillation of about 60-year time scale, the Pacific Decadal oscillation, which we can verify and substantiate, of about the same. And then you were kind enough to show the cover of my book, which shows evidence for a 1,500-year oscillation.
Well, you talked about my book, so I had to.
What?
You talked about my book, so I had to show your book.
Okay. Thank you.
Can we go next question? Yeah, go ahead.
Quick question, Dr. Singer. You were worried about the
Yeah, essentially, your book shows sea level rise, a curve, and the correct one. I checked it. I had a chance to read some of your book this afternoon, and I noticed that there was no increase in sea level rise, no acceleration between 1910 and 1940. Why is that?
No acceleration in sea level rise. I think probably what you said was right, which is, there's a lot of inertia. And also,
There was strong warming between 1910 and 1940.
That's right.
So the sea level should have responded, but it didn't.
Yeah, to be honest, I would have to look, again, a seminar is not the right place to argue about things that are far outside your, I have to look at
so we'll wait till tomorrow.
But we have an oceanographer over there, so Doug?
Let me just ask one quick question, and that's you were concerned about the validity of the weather station data. Is the worry there that the weather stations, some large percentage of them are close to urban centers, and there may be an urban heating effect? What's the concern about the weather station data?
Yeah, so you talked about how you thought the weather station data on land was wrong, and so could you talk about what you think is wrong with the land surface stations?
I'm no expert on that. All I can do is show you the published work, in this case the work of the NASA Space Center in New York. They published the U.S. data separately, and they show no appreciable warming actually, they show that the warmest years in the United States were in the 1930s. Do you doubt that?
Yes. So we have this plot. So your plot was cut off at 2000. And so if you look here, when you showed the plot, you cut it off at 2000. You can see that the last decade, if you look at the entire record, it's actually quite a bit warmer. And so last year was the warmest year. Now, you also have to remember, 1930s was the Dust Bowl. So, you get warmer years when you have these continental scale droughts.
Well, wait a minute, did you see the Dust Bowl caused the...
Yeah, during droughts, the temperature is always higher. So if you look at a region that's in a drought...
You're not saying the Dust Bowl caused the temperatures to go high.
Yeah, during a drought, you have higher temperatures.
Well, I think the causation could be the other way.
Well, there's a feedback. So there's not an either or. If you have high temperatures, you evaporate all the soil, you dry up, and once the soil's dry, the temperatures there's no latent cooling, and so the temperatures go up.
All
and
right.
so I think that, you're seeing, there's several processes going on here.
Well,
and
they published their work up to 2000, so that's what I used.
Well, I got this yesterday.
Okay.
Or 2 days ago. It is available.
Yeah, it is
right.
available. Good.
All right, maybe one more question.
I agree with this.
That's I pulled that right off their website.
But it doesn't agree with the satellite data.
I think it does.
It doesn't. It doesn't. No,
Okay,
show the
well,
satellite.
you guys
all
can do
right, so we'll discuss it. One more question, and someone who had their hand
the
up for a
satellite
while.
data-
So yours first. Who's was first?
Does not agree.
I just have a quick question. According to your graphs, you stated that the scientific agencies use the same data source. So what do you suppose that they use?
Okay, so the question is, when you look at the surface temperature record, you said that all of them are analyzing the same data. And so, and that is correct. They're all analyzing their various surface data sets but they all adjust it differently. So they apply different urban heat island adjustments, homogenization procedures. When they move the station, they have to adjust it for that. So that's all independent, but the raw data going into all the surface thermometers are the same. So that is correct. All right, last one.
You say that it was warmer now than it was 100 years ago. Would you relate that to the Industrial Revolution and how we started humans started to become more dependent on cars, and therefore that was how the CO2 increased? So isn't that like an evidence that shows that temperatures have increased due to CO2 has increased and the fact that we are more dependent on fossil fuels now?
All right, so let me reimagine that question. So you say it's hotter now than it was 100 years ago, and we know carbon dioxide was increasing. Now, we don't know what the sun was doing in the first half of the 20th century, but isn't it possible that all of the warming, or most of the warming over the entire century, is due to carbon dioxide?
Well, it is possible. Theoretically, you can imagine that. However, we have to take into account the history of climate, and we know there was something called a little ice age, when temperatures were extremely low. I have a slide on that. That goes back 1,000 years. I showed it. It's from the Climate Research Unit at East Anglia University. And the warming started around 1800. Long before there was much carbon dioxide in the atmosphere. So it's a recovery from the little ice age.
But there has to be a mechanism. I mean, that's not an explanation. I mean, there has to be, and there could be several mechanisms. Right, so it could be solar's getting a little brighter, but then there's also carbon dioxide. I mean, isn't that also a legitimate possibility?
Not really, because the concentration of carbon dioxide only started to rise appreciably after World War II. But you can fiddle with data and try to prove all kinds of things. I'm satisfied to think that this was at least mostly a natural recovery from the little ice age.
Okay. Here's to fiddling with more data.
That's right.
And let's thank the speakers.